this lesson, we will continue to explore exponents and their connection to radicals when the exponents are rational exponents, also known as fractional exponents. So to get warmed up, consider this 25 square foot garden, and if you know that the area is 25 square feet, what is the side length? Well, you should remember that 5 times 5 is 25. You're basically taking the square root of 25 to get 5. So 5 feet is one side length. Let's consider this swimming pool problem. This is a volume problem. The shape is a cube and has a volume of 27 cubic meters. What is the length of one of the dimensions? That's the length, width, or depth. This, or this. So basically we need to know what number cubed is 27. In other words, we're looking for the cubic root. And a cubic root of 27 is 3. So today we're going to further explore square roots, cube roots, and higher roots. So this calculator activity will help you discover the relationship between a radical expression and an exponential expression. So we all know that the square root of 4 is 2. And the square root button on the calculator is located right here. Second square root 4, close your parentheses, and the answer is 2. Cube root of 27, now there's actually a function for cube root on the calculator as well. You have to go to Math, scroll down to option 4, which is cube root, and like we discovered in the swimming pool example, the cube root of 27 is 3. So in order to take the higher roots than cube root, so 4th root, 5th root, and 6th root, you need to actually store a value into x. So we'll see how to do that. So we want to store the value 5, use the store button, STO, into the variable x. Press enter, and now it's stored. So we go back to Math, and this time we go to option 5. This is the xth root. And the xth root, which has the value 5 in for x, means you're taking the 5th root of 32, and the answer is 2. So we know this is 3, this is 2, and after doing a couple more of these, we end up with these answers for the radical expression. Now let's go ahead and evaluate the exponential expressions. For example, 729 to the 1/6 power, you must use this caret symbol. Use parentheses because we're dealing with a fraction, a rational exponent. And it evaluates to 3. So after completing this column, we see that there's a connection. All the answers are identical. Now the reason, hopefully you will discover, is that, well, there's a pattern here. For example, the square root, which has an invisible 2 as an index, can be rewritten as 4 to the 1/2 power. The cube root of 27, or the third root of 27, is really 27 to the 1/3 power. The 4th root of 625 can be rewritten as 625 to the 1/4 power, so on and so forth. And this brings us to today's rule. So a little vocabulary first. Rational is also known as fractional exponents, are an alternate way to express roots. So as you can see here, x to the m over n power is the same thing as the nth root of x to the m power. Well, if we use numbers instead of these letters, these variables, we have 5 to the 2/3 power, which is equivalent to the cube root of 5 squared. And you will also notice that this expression here can be equivalently written as the cube root of 5, all in parentheses, squared. They're exactly the same thing. So continuing with the vocabulary, the denominator of the rational exponent becomes the index of the radical. So like I said, the index is what belongs right here in the radical symbol, and the numerator becomes the exponent of the radicand, and the radicand is the expression under the radical symbol. As you can see here, the index becomes the denominator of the fraction, and the power under the radicand is the numerator and can also be the power of the entire expression. So as you can see, the cube root of 8 squared can be rewritten as 8 to the 2/3 power, and the 5th root of 32 to the 4th power can be rewritten as 32 to the 4/5 power. Now, to evaluate these expressions, hopefully you know that the cube root of 8 is really 2, because 2 times 2 times 2 is 8. And 2 squared is really 4. So we have evaluated this expression. And I guarantee if you plug this in the calculator, you will also get 4. And over here we have the 5th root of 32 is 2, and 2 to the 4th power is 16. This time we're going to rewrite the exponential expressions as radical notation. 5 to the 1/4 power is the 4th root of 5. 7 to the 1/3 power is the cube root of 7. 14 to the 2/5 power can be written as the 5th root of 14 squared, or parentheses the 5th root of 14 close parentheses all squared. 21 to the 9/4 power can be written as the 4th root of 21 to the 9th power, or parentheses the 4th root of 21 close parentheses to the 9th power. Down here we have a negative exponent, and if you remember from previous lessons, a negative exponent is simply the reciprocal of the positive version of this. So that's why I put a 1 under this to make it into a fraction. So we reciprocate the entire expression, and we end up with a positive 4/3, which is the same thing as 1 over the cube root of 7m to the 4th power, or if we keep the power under the radical, it can be 1 over the cube root of 7m to the 4th power. Over here we have 1 over the cube root of 4r squared, so we're going to rewrite this as an exponential expression. So it's 1 over 4r all to the 2/3 power, which can be rewritten. If we bring this up to the numerator, we're actually going to negate this exponent, making it 4r to the negative 2/3 power. And let's go ahead and do a little matching activity. We have 2 to the 1/3 power, which matches with c, the cube root of 2. 2 to the 3/2 power matches with a, the square root of 2, cubed. 2 to the 2/3 power matches with d, the cube root of 2, squared, and that leaves b for 6. 2 to the 1/2 power is really the square root of 2. Good luck to you.